So we're going to move the log base 6 of 16. That's now 4 log base 6 of x equal, but no, minus, I apologize. Log base 6 of 16 is 0, right? So now I see that I can use this rule to move from expanded form to condensed form. So now I can write it as a single log, right? And divide. The second term, the 16, goes into the denominator. Yeah. But what about that 4? So I have a log base 6 and a log base 6. What about this 4? The 4 is this r, right? So the 4 can go up here. So before I turn it into a fraction, I'm going to use this rule to move my r from out in front of the log to an exponent of the variable x. So that becomes log base 6 x to the 4th minus log base 6 of 16 is 0. Now I'm going to subtract. Or sorry, I'm going to use the subtraction, change it to a fraction. So they were both log base 6. X to the 4th, the first term goes on top, as I said, and then the second term goes on the bottom. So we have x to the 4th over 16 equals 0. Correct? Okay. Now I want to, what can I do? What can I do here? Now I can convert. I can go in a circle, right? Start with my base. I'm going to convert it to an exponent. The base is 6. 6 with an exponent of 0 is equal to the fraction x to the power of 4 over 16. Good. We can keep simplifying it. Anything to the power of 0 is 1. So now I have 1 equals x to the 4th over 16. I'm solving for x, right? Currently, x is being raised to the 4th and divided by 16. So to solve for it, I want to do the opposite of dividing it by 16. Multiply by 16 on both sides. I get 16 is x to the 4th because those two cancel, right? Okay, now get rid of that 4th power. I'm going to take the 4th root of both sides. I'm taking the 4th root, I have to include the plus and the minus because there's a positive root of 16, 4th root of 16, and there's a negative 4th root of 16. Good. Here, that cancels that, and I just have x. What is the 4th root of 16? You can, if you have this button on your calculator, you can go like that. Or you can just say 2 to the 4th, right, is 16. So x is either positive 2 or negative 2. Good. Now we want to check our answers. We got x is negative 2, x is 2. All right, always check your answer because if you recall on, a while ago when we were first introduced to logs, there is a rule about logs. So 4 log base 6 of 2 and log base 6 of 16 should give you the same exact number in your calculator. And 4 log base 6 of -2 should also give you that number, right? It does not, because you cannot take the log of a negative number. So anytime you get a negative, omit that answer. Let's go to the next example. The next example is log base 20 of x plus 9 plus log base 20 of x plus 1 is equal to 1. What we want to be doing is solving for x. So think about how these rules and how converting between logarithms and exponents can help you to isolate x. Okay? Look at this, right? We are taking a log, we have a log base 20 plus another log base 20. So if they are both the same base and they're being added, we can instead multiply them. So the first thing I would do here is take log base 20, and instead of x plus 9 plus log base 20 x plus 1, I would say log base 20 x plus 9 times x plus 1. So basically what we're doing today is we're using these rules, but we're doing algebra. As long as you can think of ways to use these, most of the skills we're using besides applying one of these is just algebra skills, okay? So for example, here we're just foiling. Log base 20 of x squared plus x plus 9x plus 9, right? Equals 1. Log base 20 of x squared plus 10x plus 9 equals 1. And just like we changed it here, just like we changed it in this example, we're going to change it in this example. Start with your base, 20 to the power of 1 is equal to x squared plus 10x plus 9. Good. By changing it from 2 logs to a single log, I can now put it into exponential form. Now it's a quadratic equation, right? So now I know what to do with the quadratic equation. That's just 20 quadratic equations we've done a lot with. I'm just going to move that 20 over so that it is in standard form. 0 equals x squared plus 10x minus 11, right? You can factor it. You can use the quadratic formula. We're just trying to find our x values. So we went from 2 logs being added, multiplied because they had the same base, we multiplied those 2. We got a quadratic formula for our log base 20 of, there's a quadratic formula here, but it was 1 log, so we were able to change it to exponential form. This was a 1, so it was just 20 to the power of 1 equals that whole quadratic equation. Now we can just make it as simple as x squared plus 10x minus 11. If you remember, it's just multiply to equal a negative 11, add to equal 10. So that's just going to be x plus 11, x minus 1, right? And then we solve each of those for x. So x is a negative 11. Here, x is 1. And again, you can check it with your, put it into your calculator to make sure. And because we're using logarithms, we're going to omit any answer that is negative. So it's x equal to 1. I think we know that if we put in negative 11, we will not get. We'll get an error, just like when we put in negative 2. So log base 20 of 1 plus 9 is 10 plus log base 20 of 2 is 1. Third example. Natural log of x plus the natural log of x minus 1 is equal to the natural log of x plus 15. So those are all logs with the same base, right? Because it's a base e. What should we do first? We have it in expanded form, so that log is being added to that log and it's equal to that log. What we've been doing when we have the expanded form is we've been putting it into a single logarithm. So let's take that x and that x minus 1 and put it into a single logarithm. The natural log of x times x minus 1 is the natural log of x plus 15. Good. If I did this, if I did the algebra, it would just be x squared minus x, right? Now what should I do? What have we been doing with to solve for x so far? We've been moving if there's anything in front, right? We move it up. We move this over, right? So maybe we can move this over now. So I just use subtraction, right? If that's a positive, then I'm going to subtract it from both sides so that it's set equal to 0. Now all of the natural logs are on the same side. Now that it's a minus, just like here, we subtracted it. Once it became a minus and both of the logs had the same base, we could then put the x to the 4th over the 16. So let's do that here. Let's put the x squared minus x over the x plus 15. So it's the natural log of x squared minus x over x plus 15 is equal to 0. Good. All right. What can I do now? Remember, the natural log means log base e, x squared minus x over x plus 15 is 0. What we've been doing once we got it down to a single log is we take that base, and we convert the whole thing to an exponent. E to the power of 0 is x squared minus x over x plus 15. Good. You have an e in your calculator, but you also know that anything raised to the power of 0 is 1. Now we know that 1 is equal to x squared minus x over x plus 15. So now that we've made all the correct decisions about how to simplify it, now again, we're just using algebra. Good. So algebra tells us in this situation, when I want to solve for x, and I have a fraction, is to get rid of the fraction. So to get rid of the denominator, I'm going to multiply by x plus 15 on both sides. X plus 15 times 1 is just x plus 15. These two cancel, right? So I just have x squared minus x is equal to x plus 15. Yeah. All right. Just like we did with example B, now I have a quadratic equation, right? Because I have the x squared, I have the linear x, and I have a constant. It's just not in standard form yet. So what I'm going to do is put it in standard form. I'm going to move these over here because I like my first term to be positive. So let's subtract x. Shoot, I'm losing my voice. X minus x. Let's subtract 15. Ooh, let's do them both at once. Subtract 15 the last day, right? 0 equals x squared minus 2x minus 15. Right? See if you can factor it. We need two numbers that multiply to equal negative 15 and that add to equal negative 2. Probably a negative 5 and a positive 3, right? So 0 equals x minus 5 times x plus 3. So in the end, we're just doing algebra. We're using the rules, simplifying, condensing, changing it back to an exponent, and then we're just using algebra. So 0 is x minus 5, so x is a positive 5. 0 is x plus 3. X becomes a negative 3. X is 5 and x is negative 3. But we're not going to use the negative 3. Oh, sorry, that's very diagonal. X equals 5, make sure it's true. The natural log of 5 plus the natural log of 4 is the same number as the natural log of 20. How many parentheses? It's true. Now let's look at just 3 exponent examples. Good. So for this guy, I have 3. Gosh. Yeah. 3x equals 7. 3 to the power of x equals 7. Oh, 3x equals 7 would be so easy, right? 3 to the power of x equals 7. What value do we raise 3 to get a 7, right? 3 to the power of 1 is 3. 3 to the power of 2 is 9. Something between 1 and 2, right? Let's convert this immediately to a logarithm. All right, so start with your base. Log base 3 of 7 is equal to x. Good, so we just went in that circle. Log base 3 of 7 is equal to x. That is the same as, remember, oh, we're done, right? I can put that in my calculator. Log base 7 over log base 3 if you don't have a calculator that does log bases. Log base 3 of 7 or log base 7 divided by log of 3. So our answer is, we're done. 1.77, 3 to the power of 1.77124. I know, I don't know why I typed all that out because I could have just put in response or I could have stopped at any point, but I just kept going. Okay, so it's close. 5 times 4 to the power of x equals 3. Let's simplify it as much as we can. This was just 3 to the power of x equals 7. But here we're multiplying the 4 that we're taking that has the exponent by 5. So if I divide both sides by 5, I'll have x better isolated, right? It's the first step. 4 to the power of x equals 3/5, right? So now it looks like this. Let's start with our base. Log base 4 of 3/5 is equal to x. Done. Just like that. So we can say log of 3/5 divided by log of 4. We get negative 0.368482797. 5 times 4 to the power of the answer is 3. So that means x equals 0.368, but it's a negative, negative 0.368. Good. Okay, last one. 7 to the power of x minus 3 is equal to 2 to the power of 2x plus 1. What rule can we use right now? If they have the same base, we could say x minus 3 is equal to 2x plus 1, but they don't, right? 7 and 2 are not the same base. There's nothing that 7 is a multiple of except 7 itself, right? But if we could, right? If we could get those down in front of the log, if these were logs, we could get it down in front of the log, the exponent, right? So let's take the log of both sides, all right? When you take the log of both sides, you can use any log base you want. We use base E in higher math. So instead of having 7 to the power of x minus 3 equals 2 to the power of 2x plus 1, I know this is a lot for like the last moments of our class, but what I want to do to them, if I don't know what else to do with them, is take the natural log of both of them. So the natural log of 7 to the power of x minus 3 is equal to the natural log of 2 to the power of 2x plus 1, just because that equal sign is maintained if everything I do to this side, I do to that side. You can do whatever you want to either side, right? Okay, so now I have taken the natural log of both sides. Now I can start using these rules about log. One of the rules is that I did this for is so that I could use the rule that a number raised to a power, the log of a number raised to a power is the same as that power being multiplied by the log itself. So now I'm going to say x minus 3 times the natural log of 7 is equal to 2x plus 1 times the natural log of 2. Let's distribute that x minus 3. Ready? X times the natural log of 7 minus 3 times the natural log of 7. I don't want that to be parentheses, so I changed it to an L. Now let's distribute the 2x plus 1. Now I have 2x times the natural log of 2 plus the natural log of 2, right? Because that's just the number 1. 1 times the natural log of 2. Is that okay? Remember, I'm solving for x. There was nothing else I could do except distribute those because they're being multiplied, right? But now there are things I can do. I am going to move all of the x's to one side. I'm not going to combine, like, this is a natural log of 7 and that's a natural log of 7, so I'm going to put them together. I want to put the x's together so that I can still solve for them, okay? In that case, I need to, I'm going to put it over here, subtract 2x natural log 2. add 3 natural log 7, add 3 natural log 7. Good. What I get is x natural log 7 minus 2x natural log 2 is equal to natural log 2 plus 3 natural log 7. Still solving for x, so let's factor out the x. Good. So now I have x times the natural log of 7 minus 2 times the natural log of 2. Nothing changed over here. I just took x out of x natural log minus 2x natural log. Good. Now, because I factored it out, I want to solve for x. I want x alone on this side. I'm going to divide both sides by natural log of 7 minus 2 natural log 2. I'm divided by natural log of 7 minus 2 natural log 2. Anything I do to this side, I have to do to this side. So I'm dividing it by a natural log of 7 minus 2 natural log 2. Too many parentheses. That cancels that, and I just have x is equal to the natural log of 2 plus 3 natural log of 7 over the natural log of 7 minus 2 natural log 2. And we can put that in our calculator. Natural log of 2 plus 3 times the natural log of 7 divided by natural log of 7 minus 2 natural log 2 is equal to 11.67. Minus 3. So if I take, sorry, so that was my x, minus 3, if I take 7 to that power, I get that number. And then if I take 2 to the power of 2 times 11.67, I get that same number, very close to it. So that is x is equal to 11.67. And that is all you need to know for this course. Again, definitely come back if, I'll leave it over there. Come back if you want to go over the exam study guide on Friday. Email me if you have questions, and thank you so much. It's been a pleasure. Have a wonderful Christmas. You guys can go.